Humbug Whistle? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
For this question, we're considering 4 springs, each with a spring constant of k. The total period I write as t, it's 0.37 seconds. In here is equal to 4. This is the number of passengers. It's also the number of springs. And the mass of the car without the passengers is 1,560 kilograms. What's the mass of each passenger? Okay, to do this, we're going to use the fact that the angular frequency omega is equal to the square root of the effective spring constant, which is 4 times the standard spring constant, since we have 4 of them, divided by the mass. And this here is the total mass, so we'll call it m sub t, the mass of the car and the mass of the passengers. But also by definition, omega is equal to 2 pi over the period t. So in other words, we can solve for the total mass, and we get the total mass, m sub t, is equal to t squared over 2 pi squared. So we can go ahead and pull that square out front of all, or outside of all of it. So this would be t over 2 pi squared multiplied by 4 times the spring constant k. Okay, but the total mass, m sub t, is also equal to 4 times the mass of each passenger, since each passenger is assumed to have the same mass, we'll call that m sub p, plus the mass of the car, m sub c. M sub p, the mass of the passengers, is what we want to find, and since this is also equal to the t over 2 pi squared times 4k, which since 2 squared is 4, that's going to cancel with the 4 and the k, so this is going to be t squared over pi squared times k. If we solve then for m sub p, we find that m sub p is equal to 1/4 times t squared over pi squared times k minus m sub c. Plugging these values into the expression, we find that each passenger is equal to approximately 61 kilograms, which we can box in as the solution to our question.